And good morning, everybody. It's 10 o'clock where I live. Time for Unhindered by Coding. This is Nick Fee. We're going to be programming, well, actually, we're writing documentation for programs written in Rust today. Hello, Izitsu. Wonderful to see you again. It's been 3 weeks, plus yesterday. I streamed yesterday, but before that it had been several weeks since I had streamed because there's been a lot going on. And some of it's family stuff, but some of it is I was at GECCO last week. Actually, I was here at home attending GECCO remotely, which was a trip. GECCO was in Malaga, Spain, which is 7 hours later than me, which meant that some of the sessions, hello Eustace, started at 3 in the morning. And so I had a very strange sleep schedule for the last week. And I'm still kind of, I'm suffering jet lag upon return to this time zone, but it was good. And so I figured, good luck with your hashing in Java. I figured I'd start by just recapping some of the stuff that happened at GECCO, since been doing that for the past 5 days. Okay. And in Java, how do you have access to the hardware instructions? I have no idea. I've never actually looked into anything like that. So GECCO, which kind of defeats the point, which is too bad. GECCO's this one of the probably two largest evolutionary computation conferences. There's an IEEE conference, CEC conference on evolutionary computation, that I think is the other big one, I would argue. Then there's a number of smaller ones. Evo Star is a very nice event. It's in April usually. So I've only ever been when I've been in Europe on sabbatical, which is a bummer because I've really enjoyed it the times that I have been. But it's at a really awkward time in the school year, so I've never been when I was teaching. And there's FOGA, Foundations on Genetic Algorithms. There's PPSN, Parallel Problem Solving Through Nature. So there's various other smaller ones. But GECCO and IEEE's CEC are probably the two big ones. And I have, for historical reasons more than anything else, tended to go to GECCO. For various reasons, going to Malaga wasn't really an option, so I attended remotely, which, if you're interested, is reasonably cheap. It's like $150 more or less to sign up remotely if you're not presenting. But that's a lot if you're, not all that interested. But for a week of content, it's actually pretty good. Yes, and I suspect they don't want you to use the JNI library and Lotus C library. I don't expect that's actually the intended outcome. So there were 5 days. The first 2 days, Monday and Tuesday, were workshops and tutorials. And then the conference proper, the paper presentations and such, were Wednesday, Thursday, and Friday. The big story, which I think is not a shocker, but useful to get out of the way, is LLMs are, the thing. And everybody, excuse me, I got the coughs here. LLMs are, a big deal. Everybody's using them and trying to figure out how to connect whatever they're doing to LLMs because, well, that's the world we live in. So there were some that were using evolutionary computation to try to improve LLMs, like evolving prompts. That seems to be a big thing. Evolving network architectures is another issue. There was some stuff on compressing network layers using evolutionary computation to compress network layers. Yeah, I mean, I think that obviously including LLMs somewhere in your title makes it easier to get research funding, no question. um, and we're not doing a job search right now, but if we were, I suspect that we would find a bunch of people who were basically doing X, whatever it is that they normally did, but they're talking about it in terms of LLMs, like X as an application of LLMs or X as a way of improving LLMs. So yeah, that's definitely a thing. One of the things that I thought was super cool and lines up with some stuff that I've thought about doing, sort of, although there were people that had clearly thought about it more than me and like had like actually I think gotten some ideas and some things working. And that was using LLMs to improve EC systems. And one of the most interesting things was using LLMs to try to find interesting mutation and crossover operators, and as find new ways to explore the search space. And so one of the things in evolutionary computation that is particularly problematic or at least confusing in genetic programming, where we're evolving code of some sort, is there's this notion of locality. So you have a genome, a thing you're evolving. So like in the push case where we're working on things, that's the plushy genome, the list of instructions. That's the thing we're evolving. We mutate and recombine lists of instructions to make new programs. In tree-based GP, you have these syntax trees, and you take chunks out and replace them with other chunks to make new trees. And so there's a notion of locality there at the syntactic level. How likely are you to be able to move from one syntax object to another syntax object, from one plushy genome to another plushy genome, or from one excuse me, you're all going to watch me die live online, from one tree to syntax tree to another syntax tree. So there's a notion of locality there. How easy is it to move from one thing to another in that space? Then there's performance locality, which is like what's the behavior like? So for two given things, two given plushy genomes, two given syntax trees, how similar are their behaviors? If we look at how they perform on a bunch of test cases, how many of the test cases have the same value or close values, and which test cases have like wildly different values. And what, in a perfect world, one of the things you would like in an EC system is for the syntactic locality to line up with the semantic locality, that you'd like small changes in the syntax to correlate with small changes in the semantics. Now, you're not going to be guaranteed to get that everywhere. I mean, there's like pigeonhole principle arguments that say that can't happen, but you would like it to be sort of true. Well, there's actually no reason to think that it is true. I mean, in fact, there's good evidence that it isn't true for a lot of genetic programming systems, especially tree-based systems. The locality is wildly different in the behavior space than in the syntax space. Now, I think that, and nobody's ever proved this or done any work on it, and somebody should, and looking at myself in some ways here, I don't think anybody's done any good work on like plushy genomes and locality there. And I suspect, but again, nobody's done the work, that one of the reasons UMAD and plushy genomes work well together is that there is good locality. That's the things you can reach via UMAD from a given program are often have similar behavior to the parent. I don't know that for sure. I haven't looked into it in any detail, but it seems plausible to me that might be true. Well, some of the people were doing with LLMs, which is very cool, is that they were taking a bunch of programs and they were evolving LLMs that could take an input program and output a program, and I forget what their representation was, to be honest with you, but it doesn't really matter. But they would take an input program and they would output a program that had similar but not the same behavior. So they were using the LLM to find things that were behaviorally similar to the parent, without having to worry about having some kind of fixed operator or fixed set of operators. And I thought that was a really interesting idea. And it would be interesting to explore some of that in the context of push in my copious free time. So yeah, that was cool stuff. There was some neat visualization stuff connected with LLMs that I would be interested in looking into. There was a lot of fundamental stuff that's still being talked about, things that in some sense I would have thought were kind of, long gone, but they keep coming back. A lot of people are using tree-based GP. I'm always kind of amazed that anybody uses that because I just don't understand it. But it keeps working for them, so they do, and I can't argue with that. So there's a lot of that. And there was a nice tutorial on representation by Franz Roloff. And there were a lot of ideas there. So I think, yeah, we probably should have an EC tree package, to be fair. I mean, I realize that, that does not make our job easier given that, we've got lots of stuff that we haven't done. But I think that if it would increase uptake, if unhindered-ec had a tree-based system with an emphasis on, especially with sort of, in an ideal world, we have everything. But there are a lot of people who think of genetic programming as being tree-based genetic programming. And so if we have that, they're going to be, we open ourselves up to a much broader audience. I think that and grammatical evolution would be the two big things to add in terms of increasing our GP user base. And I think in fairness, I think most of the tree-based stuff is used specifically for symbolic regression. So you're looking for an expression, not a full program, that maps inputs to outputs. So you've got a bunch of input data and output data, and you're trying to find the function that captures whatever the relationship there is. And there's a lot of application work in symbolic regression. It's a big area, probably one of the largest application areas for genetic programming. And so I think if we had, tree-based GP and some kind of state-of-the-art symbolic regression tools, that would appeal to a large group of people, especially if it's fast. And so that's a thing. So that's that part. One thing that I thought was very fun that made me very happy. So ACM, big trade organization in computer science. ACM and IEEE are kind of the two big international trade organizations. And ACM has special interest groups, SIGs, and one of those is SIGEVO, Special Interest Group on Evolutionary Algorithms. And they're the sponsor, in some sense, of GECCO. And they have an SIGEVO Impact Award every year that highlights a paper from 10 years previously. So it's looking for something 10 years back. It's called the Impact Awards. You're looking at a paper from 10 years ago that's had some significant impact downstream. And the Impact Award this year went to Tom Helmuth and Lee Spector for Tom Helmuth's paper on the software synthesis benchmarks from 2015 that we have actually talked about and I've used as examples a number of times in the stream. And so that paper won the Impact Award. It's PSB 1. PSB 2 came from a later paper. So PSB 1 didn't have that name. I think when the 2015 paper came out, I think that sort of that naming scheme, I think PSB sort of evolved as a abbreviation. And PSB 2, then when that paper was written several years later, 5-6 years later, Tom decided to call it PSB 2 and retroactively call the original benchmark set PSB 1. So it's an individual, so it's for an individual paper. And so it was very specifically that paper from 2015 that won the award, which is very cool. And I makes me very happy because I was actually on sabbatical in Massachusetts. So Tom did his PhD at UMass Amherst, University of Massachusetts at Amherst. Lee Spector was his advisor, and I was there working with Lee, actually. I didn't know Tom when I set all this up. But I ended up doing a lot of work with Tom while I was out there. And he was finishing his PhD, and this paper is sort of the main paper to come out of his dissertation. And so I got to sort of see all that happen while I was there and see the paper get published. And now 10 years later to see, it win this award is actually super nice. I mean, it's hello, Vagary. Wonderful to see you. So I'm just babbling on about GECCO at the moment. So I think the paper, it's been cited a bazillion times, which is part of the impact. I think it was important. I think there were two reasons it was important. And unfortunately, I think there was a little like, here's why, here's this year's winner and why we nominated it. And I missed that presentation because that was at 3 a.m. On Wednesday morning. Oops. I didn't get up quite early enough for that because I didn't know it was going to happen. I didn't realize that they'd won the award, or I would have, and that they were going to talk about it at 3 a.m, or I would have probably gotten my butt out of bed. I think there were two main, well, I would, and especially if then the plan is to stay up for the next 9 hours listening to people be smart. That's hard. That's a lot of mental effort. So I think there were two main things that paper did from my perspective that were important. And one was provide the first good, comprehensive set of benchmarks for software synthesis specifically. There have been a ton of stuff on symbolic regression and things like that, but I think this was the first attempt at a large, broad, fairly general set of test problems for genetic programming for evolving programs with things like loops and conditionals and stuff. Yes, I appreciate sarcasm. Thank you. Sorry if I sounded a little overly serious. So I think that was important, and that's probably why it's been cited the most, because a lot of people have used those test problems as examples. And then the other thing, which I think is not always appreciated, is it is in many ways the first paper to demonstrate pretty convincingly that lexicase was a very good idea. Lexicase, it has a weird history because the first lexicase paper was actually just a poster. It was a pretty short, understudied idea at that point. And so if you want to go back to the original thing, you would cite this 4-page poster paper, which doesn't actually say very much. And so I think, I'll get to that question in a second, Eustace. I think that if, for a lot of people, Tom's paper was the first paper to just make it super clear that lexicase was a very good idea, because he used this set of benchmarks to show that lexicase was quite a bit better than tournament selection on its own, or another related idea called implicit fitness sharing. And so I think that the paper both provided this set of benchmarks, which was cool, but also said, hey, lexicase is really like good, and we should like be using it more. And so I think that some of the citations are about the benchmarks, but some of them are just about, oh, this is sort of where I learned about lexicase, so I'll cite this paper when I talk about lexicase. And so I think it's had a lot of impact in both of those ways. Okay, so Eustace asked for a reminder of how lexicase works again. So the central idea, let me back up a little bit. Historically, it was common to just add up errors when one was computing fitness for some thing. And there were lots of different things that had multiple errors. Some things just have a single value, and then it doesn't really matter. But if you're doing more interesting problems, there's usually well, and I think one of Lee's strengths is he's good at simpler reactions to things. He's done a good job at a variety of key moments of having simple versions of things that have worked well. So, let's say you're trying to find a classifier that takes some inputs and says, this is a red wine and this is a white wine, or this is the digit 7 and that's the digit 9, or whatever. So you got a whole bunch of test cases and you have some sort of score for each one. What do you do with that? And the simple thing, which was what was done for many, many years by most people, and is still done a lot, although I think a lot less, was just add them all up or average them or some version of that. So you had combined all this stuff into a single value. And an alternative, which it vaguely suggests, is to use multi-objective optimization. So you keep them separate, but then you use fairly complicated algorithms like NSGA2 or similar to decide who you're going to select out of this. And that's kind of complicated. So Lee and Tom, actually, this comes from Lee and Tom. I think Lee came up with the basic idea, and they were joint authors on the poster paper, came up with this idea of lexicase. So the idea of lexicase is and same for multi-objective optimization, as Vagri mentioned, is you keep all these test results separate. You don't aggregate them. So that's one of the central arguments, is don't aggregate all your test results, because aggregating is just not helpful. There's just a whole lot of ways that doesn't work well. And it tends to often encourage systems that give you reasonable average performance, because that's what you're testing, is average performance. But reasonable average performance is often unhelpful. And you would rather have systems that perform well in some places and poorly in other places, and preferably be able to maintain a population that has, for all your different test cases, somebody who does well at a given test case. And the hope then is that recombination and mutation will bring all that together and give you a solution to the overall problem. So how does lexicase work? It says, okay, we'll keep everybody separate. So we have a vector of results. And so every individual has a vector of results. Let's say there's 100 test cases, just to keep it simple. Actually, let's make it 10 to keep it simple, even simpler. 10 test cases. And whenever you need to select a parent from the population, you shuffle the test cases. So there's a random order of test cases. And let's say the first test case in that order is test case 7. Now you compare everybody on test case 7 and you look for what's the best performance on test case 7. And let's presume there's going to be several individuals with the same performance, same best performance. You keep everybody that had the best performance on test case 7. Let's say there's 10 individuals that are perfect, have 0 error on test case 7. You keep those 10, you throw out the other, let's say 90 individuals if we have a population size of 100. So you've reduced your population from 100 down to 10. Now you move on to the next test case in the random order, which might be, say, test case 3. And so just looking at those 10, you look at how they perform on test case 3, and you say, oh, look, well, 4 of them got a 0 on test case 3. So you throw away the other 6. Boom. Now you've gone from 100 to 90 to 4. And now you go look at the next test case in the random order. Let's say that's test case 9. You see who does the best just out of those 4 on test case 9. Maybe there's only 1 that does well on that one. So you keep it, throw out the others, and that's now your parent. Boom. And you do that with a different random order of the test cases every time you select a parent. So yeah, I think we've got, oh yeah, well, set aside rather than throw away. Fair point. Because they're still in the population for potential selection next time. So yes, that's actually an important distinction. It's a subtlety that I'm bad at subtlety, so I blew that one up. But Vagri's completely right. We set them aside for now because they do come back into the population for the next time we do selection. So yeah, so LexCase works really well, and there are variants on it. It turns out for real valued problems, exactness is a challenge, as it always is with like floating point stuff. And so there's a thing called epsilon lexicase that says if things are close enough, we'll keep them instead of setting them aside. So we don't require that you be exactly the best, but if you're close to the best, we'll keep it. And that tends to work better on things that have real value or floating point values, and kind of regular lexicase is just epsilon lexicase with epsilon set to 0. Then there's the other big one at the moment that has clearly, I think, demonstrated some real value is downsample lexicase. One of the problems with lexicase is it's slow. You're doing a lot of work every time you do a selection, and that makes it pretty slow compared to, say, tournament selection. And so downsample lexicase is a way of speeding things up considerably that has shown to not hurt the performance too much. So it creates an interesting trade-off. And so in downsample lexicase, like the simplest version is every generation you identify a subset of the test cases and you only work with that subset, random subset, for that generation. There's also a cohort version of that where you divide, say there's 100 test cases, you maybe divide them into 10 cohorts of 10, and you divide the population up into 10 equal-sized groups. And group A works on test cases A, and group B works on test cases B, and group C works on test cases C. And the hope is that you maintain individuals that are good at each of the different subsets of the test cases. It's not a bad idea. And that's something that actually, I think our framework doesn't make. I thought about doing downsample lexicase, and it's not entirely clear to me how we would do that in our framework. I think the design does not lean well to that. Implementing epsilon lex case would not be hard, which is a thing we ought to do. So it's expensive. I mean, everything needs to evaluate all the test cases. That's not really the issue. The issue is you are you're doing a lot of comparisons. If you say just add up all the test cases, I think we do have an issue for downsample lex case. If you just add up all the test cases, and you pick, you say tournament size 10, you pick 10 individuals and identify the best of that, like that's very cheap. If we use LexCase, then every time we select, we have to do this random sequence of shuffle the training cases, and then you have to go through and do this sort of sifting at every point. And in fact, a lot of times you end up having to sift through all of the training cases. So if there's 100, 200 training cases and a population of 1,000 individuals, you're doing kind of n times k actions in the worst case. And so it takes up, a fair amount of resource. And I've looked at our system. I think I've done a flamegraph with unhindered-ec and LexCase. If you only use LexCase and you I think that LexCase does end up being something like a quarter to a third the computational time, with most of the rest being evaluating the individuals. So it is actually not a trivial part of the computation. So let's see, what's your split at median? Just throw out the worst half of each group at each iteration. Oh, that's interesting. So, Vagary, do you find that split at median works pretty well? Because it's easy to implement. Like, we could totally add that. Yes, but so does it? So whether optimizing LexCase is a low-hanging fruit, I think depends on what you mean by a low-hanging fruit. I think that if you mean optimize the code so the code runs more quickly, yes, that could certainly be a thing. If you mean find a better LexCase, a lot of people have put a lot of energy into that and haven't really come up with much. Downsample is about the only, I think, yeah, sure. So SIMD, cache, stuff like that. If there are things there that we could do to improve the performance of our LexCase selection, that would have a non-trivial impact. My suspicion is still that that the lowest hanging piece of fruit is probably the random number generator, because we call it so many times and we're using the default and therefore fairly expensive random number generator. And I think if we were to replace that with a more performant random number generator, that it would probably, my guess is that we would see a very large improvement for very little effort if we did that. And it probably, and you've suggested this, and I think Azitsu suggested it as well, I think generalizing the code so that people can choose their random number generator probably makes sense, and then that would make it easier for us to then experiment with different random number generators. Because you want it to be random enough that you're still doing something interesting, but that's not very hard, actually. I think in EC, random enough is a pretty low bar. And you call the random number generator constantly. I mean, so many times that if we could speed that up, that would almost certainly be a win. So, and I expect you have spent more time looking at random number generators than I have. So I mean, I guess so. Yes, you could create a single stream, but it's got to be a pretty big stream. Uh, so I don't, I've never really thought about that and sort of how complicated that would be. Um, hmm. And I mean, if it sped things up enough, that wouldn't be a terrible thing. Um, so let's look at Rand, and I'm going to actually make a note about Vagry's median idea, and a deterministic lexicase involving permutations and partitions. I would definitely like to learn more about that. So let's see. So I'm assuming that this is faster. But well, no problem. I would love to see your Obsidian pages and see if they're legible at some point. That would be very cool. Thanks for joining. And I want to actually, I think making a note, issues, implement median lexicase in the 2025-0720 stream. Vagary, I guess it's technically OG Vagary. Suggested a lexicase variant that he uses that would be easy to implement and try out. He just sets aside the bottom half of the population at each lexicase step instead of only keeping the individuals that are best on the current test case. Boom. And I guess we should do labels. That would be, it's probably in there. Mutators, selectors. La 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 la. Probably medium. It's gonna need testing and stuff. Priority probably low, but fun. Okay. Was there an F? Oh, you're right. Thank you. Yep. Good catch. And this would be a feature. Boing. Okay. Then you shared a overview of RNGs. Yeah, so jitter is the one that's super, super slow, right? Yeah, very slow and has security issues, yes. So jitter would definitely be the one to use. So, and then, so here's Joshiro. Is that how they pronounce it? I don't know. So Joshiro might be a good choice. Yeah, so none of us know how to say it. Okay, well, so that would be a thing, right? Is we could try Joshiro and see how much that speeds things up. Because I do think replacing the random number generator is bound to be an improvement in terms of time. And I don't think it would affect performance in a meaningful way. Well, you say literally a one-line change, but that's a one-line change in a lot of places, right? Because you'd have to well, I don't know. Yeah, right. Aren't you? It's a matter of the imports. Just we need to replace let mute RNG equals RNG with the other one. And is that only happening once in the main? Becoming hopelessly distracted. See, examples, that's what I'm after. Count ones, main. So you think this guy right here is the only place that we, and everywhere else we pass the random number generator in as an argument. So we only have to change this one thing. Wow. Well, that's interesting. So it really would be a matter of adding the dependency to the cargo.toml, adding the import, and then running it. And it would we'd learn sort of what was going on. Well, that's interesting. Whoa. I'd be tempted to play. Let's finish the summary of GECCO quick. What time is it? Oh my, I've used 42 minutes. And then we can see where we go from there. So yeah, the whole SIGEVO Impact Award, I think that was very cool. And it was also neat that the paper from 3 years earlier that won the award, 3 years ago for a paper 13 years old now, was a paper on how GP needed better benchmarks. So let's see. So this pull request, which we merged. Aha, good job. Go Eustace. Made the world a better place. Almost 9 months ago. So well done. Okay. So in 2012, there was this paper entitled GP Needs Better Benchmarks. And then 3 years later, Tom and Lee write their paper providing a set of benchmarks for at least software synthesis problems. There's other benchmarks for things like symbolic regression. And that then went on to have a big impact. So sort of you can see the stacking up of the events in sort of a nice way. I'll mention quickly the Humies. So every year, so John Koza funds this Humies Awards that are for work that is human competitive. And there's a whole definition for what that means. I think since we're here, we could go to the Humies, that thing. Human competitive. I think that's the 1990s website. So there's somewhere. So there's 8 criteria that it was patented or improved on a patent and invention, equal or better result that was accepted as a new scientific result, as in peer-reviewed research, equal or better to something that's in a database of good stuff, publishable in its own right, equal or better to recent human-created solutions, blah, blah, blah. So different definitions what that means, but the idea is that you have human competitive work. And so COSA, in an effort to encourage and recognize that kind of work, has funded this award, and I think the top prize is $5,000 if you get the gold, and then I don't know, it's $2,000 or $3,000 if you get the silver, and then there's maybe $1,000 if you get the bronze. And they had, I think, 8 finalists this year, and they gave out 1 gold, 1 silver, and 2 bronzes. And I didn't catch who the bronzes, I didn't write down who the bronzes were, so honestly I don't remember, unfortunately. But the gold went to a project that was actually pretty cool called REA, Realizing Human Expertise with AI. And they were looking at tackling big societal problems. And so they got an X Prize funded competition. They were focusing on, as their first one was pandemic response. They got X Prize people to fund a human competition where I think it was like 80 or something submissions for different kinds of pandemic response. So the question is like, should everybody stay at home? Should, schools close? Should there be test, what kind of test and trace is being done? So those kinds of things were in the proposals. And then the bit that's relevant to the evolutionary computation, what they did is they used, for each of these human things, they found sort of a set of descriptors that included all of the human proposals. And then they evolved neural networks to imitate the behavior of each of the proposals. So for each proposal, they built a neural network to behave like the proposal suggested. And then they used neuroevolution to evolve, to starting from those neural networks to evolve new neural networks that were different pandemic response behaviors. And that was able to produce new insights into pandemic response behaviors and what makes pandemic response policies effective. That was actually super interesting. Yeah, that was actually a very neat one. And then there was one using Cartesian GP. That's another kind of genetic programming that in a perfect world we could implement in our system. Wouldn't be that hard to do, be easier than some of them. Used Cartesian GP to evolve hardware-friendly hash functions for network security. And was used to targeting DD denial of service attacks, and was aimed at being able to run very fast on FPGAs, and that was actually very cool. And so that was neat. I liked watching the Humies. I always do. Fun stuff. And then it was interesting, the 2 keynotes. Well, there are 3 keynotes. So the 2 outside keynotes, Wednesday and Thursday, were focusing on interesting subjects. So Wednesday's keynote was looking at the environmental cost of training AI models. Apparently Google's energy consumption is more than the entire country of Germany in a year. Now that's not just AI, that's all of Google's stuff. But still, I was just like, oh, that's a number. And so I was looking at that, and then were there ways that we could be using evolutionary computation to improve the energy footprint of a lot of the stuff that we're doing. And then Thursday's keynote was, I thought, very interesting. It was looking at the problems of making AI systems safe, trustworthy, and responsible, and was arguing that EC could actually be very useful in that context. And I look forward to getting his slides when his slides are available, because I think there was a lot of good stuff there. So that's the not very short version, since that took most of an hour. But that's my sort of thoughts on GECCO this year, and it was good. Certainly saw some interesting talks and learned about some cool work. So, yay team. So, so you said it doesn't break. So, thank you. Yeah, I hope that was at least somewhat interesting and not just 50 minutes of complete white noise, because that would have been sad. But I figure, a lot of people here have been tangentially interested in evolutionary computation, and oh, that's too bad. So before you leave, should we try the random number generator thing quick? Or should we wait and do that like next week as a standalone activity, and I can just like play with READMEs for the rest of today? What would work in your universe, Eustace? Oh, you need to go to GECCO sometime. Okay, I didn't understand. My apologies. Well, and hopefully you'll get a chance to. So, I meant to say it. I forgot. Next year's GECCO is in Costa Rica. The city hasn't yet been pinned down, I don't think. But I've never been to Costa Rica, but Lee has been several times and really likes it. Lee's a big fan of Costa Rica. So I haven't been to a GECCO in person in a number of since COVID, actually, for various reasons. COVID being one of them. But I might actually try to go to Costa Rica next year, in part as an excuse to go to Costa Rica. Yeah, so that it's easier for me. It's harder for those of you in Europe. Yeah, GECCO used to bounce back and forth between the U.S. mostly and Europe, sometimes in Canada, but since the various political complications starting in 2016, GECCO has been more likely to be, when it's in North America, to be outside of the United States. So it's been in Canada and Mexico when it's been in North America recently. And then I think so Costa Rica next year, I think it's back to Europe the year after, they said. And then the year after that is yet to be determined. And I think that's probably going to be in Asia somewhere if they can sort it out. Because I think they would be due to jump back to Asia or Oceania. They were in Melbourne, Australia 3 years ago. And so if they don't go back to Asia for another 2 years, or Oceania, it would be like 5 or 6 years since they last went. No, I think Australia would be more Oceania. I'm probably being sloppy in my language, but I think I would have it be more Oceania. Okay, so because I can't stand it, let's actually see if we can pop the random number generator in and see what happens. Let's see. So boom. Oh, Bacon was still running. Heavens, Betsy. Well, I think if we just start with count ones, everything else in that is very simple and inexpensive. And so if we're going to see an impact, it's going to be most notable here. And then depending on what that looks like, we could hop over to something that's more expensive. But let's start with actually the simplest thing in the possible world. Now, one thing I want to make sure is, so at the moment, partly because Lexicase is expensive, I've got Lexicase being used a lot less than Tournament. Let's actually change that to just use Lexicase, because I think that would be Lexicase New num test cases. Oh, no. What's going on? Num test cases. And yeah, boom. Oh, actually, I don't know the one there. What am I doing? There we go. And I think it uses best down here just to figure out what to print at the end, right? Yeah, so this is just being used to decide what to print as we go along. Oh, in the stuff that I commented out? Oh, you're right. Yes. Oh, so it did actually include best. Ah, you're right. So maybe that's worth keeping. Probably is, actually. Okay, fine. Let's do that. Oh, fine. And we're just, all we care about is timing. So the rest of it's just noise. So there's that. So we want to hyperfine. Oh, I guess we really want to cargo, build, release, examples, boom. Da-da-da-da-da-da-da-do. Whoa. Oh, that's just warnings. Don't care. Okay, then hyperfine, target, release, examples, count ones. What are we doing here? Should I just take the defaults? Probably would just be simplest. So we're doing it in parallel, which we probably care about. Let's go for a big population though. Let's go to 1,000. And let's go to a bigger number of bit string, bit length. Yeah, so if we increase the population size and the number of bits, I think that would be useful. So population size and bit length. Minus P 1,000 minus B 2048. Sure, that seems like a thing. Boom. Do 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 do. Okay, let me have a place to write this down so don't forget. Da 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 do 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 do. Oh, did I say 2028? I totally did. Well, oh, and actually, let's rerun it because. Oh no, count ones doesn't care. Well, let's rerun it just to be. So it looks like this is taking a little under 2 seconds. And that's actually a pretty good time because if we're going to see a difference, it's probably going to be visible here. Whoa, that's weird. We didn't have that happen before. Let's try it again. Maybe too much going on my computer. It's definitely not a clean benchmarking system. Okay, so actually 1.2 seconds. I wonder, because that's weird that it got non-trivially faster when we changed it. That's interesting. Well, I'll just make a note. Save that over here. Do 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 boo boo boo. Sure, why not? No, I think there was just something about that first run. Something was slow. Because we're actually very similar. How very odd. Okay. So then I want to say cargo add. What am I adding? is it just Rand Joshiro? Okay. Add minus dev Rand Joshiro. Boom. That didn't work. Oh, I have to tell it which package. That's why. So I need to say minus package EC linear. The integrated small one first. I don't know which one. Scroll up. Oh, this one right here. So small range. And small range already exists, right? Because that's just provided by RAND, so I don't actually need to do the cargo add on that one. Let's go ahead and do the cargo add just so that's done. And then, hello, Dotted Attitude. Welcome to the stream again. Okay, so then, oops, presumably I just want like a small range new or something, right? Small range from range. Ooh. Yeah, okay. So this, we'll comment that out. Whoops, hello. Comment that out. And boom. Okay, so that would give us a small range from seeded by a value from the standard range. That's the theory anyway. Failed to resolve. Oh yeah, of course we have to import. Import. Hello. Import. There we go. Boom. I bet that's another import. Import seedable range. There we go. Okay. So then, in theory, cargo build again. And then this. Boom. So this is with small range. With small range. Oops. And it's a little slower. Or it's about the same. One more time for fun. No. It's a little faster this time? Why does it just keep... That's so weird. I'll do one more just for grins. Oh, I did 2028 again. Arg! Presumably, also maybe has to do with, like, I hopped over to Obsidian to take a note, and maybe that caused a page swap that interfered. So, okay, looks like 1.18-ish. Yeah, I mean, I've got tons of stuff happening, so definitely not. So small runs did not make a difference or a meaningful difference. Might be a hair faster, but it was not a lot faster. So we would then, oops, back up. We want to make one of these guys. Whoa, hello. Oh, I guess that's gonna happen. Is that gonna? No, that's gonna take me out of there. That's annoying. And so I want docs. There we go. Yeah, so I can do like flame graphs and stuff. Yes, profiling. Um, this is we're definitely not doing this right. This was just I made an offhand comment earlier, and we were like, well, let's try something quick just to see if that seems to even be true. I guess. Oh, there's so many choices. I'm guessing like one of these guys, probably. So do star star. Da-da-da. Rand, Joshiro, 256 star star from Runge. And that compiles. That's a happy thing. The random number generator gets called a lot in this code. I mean, a lot. We make a lot of random number calls. And so the assumption was that a faster random number generator would speed things up, which it appears to not actually do. They're deep in loops of loops of loops of loops. So that did not make a profound improvement. Well, that's interesting. I wonder if that tells us if I mean, it's a little better, but it's certainly not a lot better. What if that tells us that I'm wrong about this, that the random number generator is not as big a deal as I thought it was? We could try complex regression for funds. I guess I don't need to be over here. And I've compiled. I do, because I have to change complex regression. I guess I first need to do it with complex regression. Minus b is not going to make sense. Is there something else here that I care about? Linear. Go away. Push. Examples. Complex regression. Main. That is spelled wrong. That's unfortunate. ARGs. What else do we have? Population size. Maximum number of initial instructions. Genome length. We can probably want the population size to be big. Might want to increase the number of generations. Yes, we could do that if we're worried that somehow that's been the case. Actually, we're pretty sure we've rebuilt them because we get different warnings from the cargo build whenever I was changing the random number generators. It was changing what the warnings were about unused imports and stuff. So I'm pretty sure it was compiling. So I don't think that's the issue. But it's probably good to check just to be paranoid. Pour myself another little cup of tea. Yeah, totally. Go for it. And so what? Wow, my fan kicked in. Why is my fan running? And that was essentially, so Vagary, who was here earlier but it left before you arrived. Yeah, why is my fan going? What is happening here? Now nothing is happening. So something clearly, I guess, actually just compiling all that stuff must have caused my fan to kick in. So okay, so then we should be able to run this. Although, do we want to go back and rerun? I guess we should rerun. Oh, yeah, really? Come on. Go back and rerun this for fun, just to make sure it didn't change anything. And the answer is no, it did not. Not anything meaningful. So, boop. Okay. So let's run complex regression. That's this will be the default initial setup. We might want to run it more generations, actually. Let's do that. Minus G 300. Oh, this is going to be a problem because the evolution, the push things end early, and when they find a solution, and so that's potentially a concern, because it's going to mess with the timing, and that's why there's going to be a lot of outliers. Let's see, can we just is there a simple way to turn that off? Yeah, I mean, I guess we could just like comment out that break right there, and recompile. Interesting. Rand XOR shift to stream it. And then let's run this. Hopefully we'll get more. So now actually running up to 300 generations is going to make it pretty slow. So actually, let's not do that. but we'll know that they're all running the same number of generations. And it looks like well, no, maybe not. I was thinking the first one is going to be long and we're going to have an outlier problem, but that might not be true. Looks like maybe just the variance is a little higher, which wouldn't shock me. Okay, so there we go. Our default, grab that. Boom. Now we want to come over here and so it's possible that if we could potentially set things up where we batch them and then we pass around again some kind of iterator thing. Problem is if you're with parallelism, you'd have to have different batches for each thread. But do you think that the existing things are actually already doing batching? Oh, actually, here's main. So this is just using lexicase. And so where is the random number generator? Up, right here. Okay. So small from, was it new range? I think. No. Oh, of course not. That's syntax doesn't even make sense. What was it? It was and mute rand range. Okay. And mute rand range. And ooh, that's not right. Oh, so that's why I didn't think this was going to be a one-line thing. So we actually have thread RNG scattered all through the thing, right? So we're actually yeah. So in here we generate one. So I think they're going to be all over the place. I think that the random number stuff, it's mostly just waiting for math to happen. So random number generators tend to do a lot of math. And, a good one's been optimized to make that math fast, but you're basically just waiting it for it to do a bunch of math. And the default is in Rust is a cryptographically secure random number generator, which we don't really need, right? That's the thing. So we were thinking that's where it would be good to make some changes. And so we've done we've used flamegraphs to identify where the slow spots are, and I'm pretty sure that random number generation was a significant piece. So Eustace, you think that if we just went and did the same thing in serial parallel, we would maybe get there, is the idea. Why am I, what is, red's over here, right? Because I was looking for, from and mute rand range. Why am I? is going on here? What did I do? What is from take? Let me undo this since I've clearly broken something. And let's go back to count ones and make the change to the necessary bit of so this is in generation, I think. Right? I guess I can come down here and say, let's look at par next. Go to definition. Yes. Okay. And your thing was we would change right here, right here as an argument. Actually, where we're passing in the random number generator is an argument. Oh, we're not passing it in. Oh, that's the issue. And so you're changing it so that we are. I'm with you. And then here, were we actually creating it? Where was runge coming from if we weren't passing it in? Oh, right here. Oh, okay. Try it with serial first. That's probably smarter. And that's here. Add the argument. Oops. Need a comma, need a comma, need a comma. I'm just trying to figure out what's changed. The problem is the gist doesn't show me the diff. So we add this argument that I've got. Oh, do I need this? Oh, I do. I need this piece here, don't I? So that it knows what R is. And that's not changing. And then this goes away. And then this needs to be imported. And mute on line 102. That's right here. Now. Yeah. It just got shifted down. Okay. So you think that takes care of that one. And then these now blow up because they don't call this correctly. And then, so we would do the same thing, essentially, for parallel. You do parallel in the background? I'm not sure I understand. Oh, so we think parallel is going to be more difficult. So we should, you're suggesting we try serial first. Gotcha. So then if we come back over here, then par serial, we need to pass it the RNG. Oh, it needs to be in mute. So we need to tell it that that's mutable. And then we could do the same thing here in case we want to do both of them. Okay, so now we have to back up to the beginning. Cargo build examples again. Oh, I want to actually go back to count ones, and let's say range. Go back to the simplest version, and let's do the same thing for complex regression. Is still actually probably the same, right? Where is range? Oh, there's main. Yeah, there we go. Okay. So those are both the same. So cargo build again. And for count ones, build failed. And that's just the other examples fail. That's okay. I don't, as long as target release examples. Did it update count ones? Oh, this is simple regression. 11. Oh no, it didn't do them. Oh poop. Oh no. Yes, it did. 26 and 26. Okay. I think it did. These dates, these timestamps are like less than a minute ago. So I think we're okay. So hyperfine target release examples count ones. Boom. Let me catch up on the chat. So no, Dota, coming back to your question, I think we only have at any given point at the moment the previous generation and the current generation. So in your example, we would have generations 3 and 4, but we wouldn't have 1 and 2 anymore. Now, there are arguments for it depends on the logging and the bookkeeping. So there are situations where you do keep track of potentially everything, although that rapidly is a huge amount of memory. And there are systems. I've certainly done things where we kept track of the parents of the individuals in the current generation, or the ancestors. So if you're doing generation 4, you would know all the individuals from generation 1 that have descendants in generation 4. And you might think that would be a terrible idea, but it turns out that actually the set of ancestors narrows very quickly, both in real biology and in evolutionary computation. And so while that's expensive, it's not as expensive as you would think. I can show you pretty graphs that sort of show that narrowing. And so we've done that. This doesn't do that, but we've certainly done things like that in the past. So okay, so let's actually go to count ones and let's try this and see what that does. And yes, that failed, but I think we're going to be okay. Count ones, yes, just recompiled, so I think we're good. If there's a population of 100 in Gen 1, do you split them out into batches of 10? Well, sort of. So we're using the Rayon package which gives us the ability to do parallelized computation easily. I didn't change this to do. Here, I need to poop. Back up. I forgot to run it in parallel or in serial mode, which your question, Dota, totally like brought to my attention. Do I have ARGs open anywhere? Apparently not. ARGs. Run model. We want that to be serial. Okay. So I need to rebuild. Because I don't know if I've got the recent build. And then run model serial. Boom. And this is going to be a lot slower. So Rayon has a sort of parallel map operator that you can use to parallelize certain kinds of calculations. And so coming to the memory question, we are evicting the entire array of individuals every generation. So there should be a whole array of individuals. It's actually, it's an array of pointers to things in heap. So we're getting rid of the array, and then that's allowing the Rust system to free up the memory for all those heap references. Not with garbage collection, but with Rust memory management system. But the Rayon system is essentially creating the new individuals in parallel. It's doing something clever about the number of processors and dividing up the number of new individuals to be made into chunks, so that it's not like one thread per new individual. But it's parallelizing the creation and scoring of the new individuals. And so that does make things go a lot faster. And like here, I turned it off. I guess I really don't need the argument, do I? In serial. Boop, bop. And I guess I could have done one more. Yeah, let's do one more for fun. Since there were outliers. Hello, Vagary. We made the mistake of believing that doing a test of a different random number generator was going to be easy, and it turned out to be more of a hassle than expected. But I think, it's like everything in computer science. But I think we've got a setup where in a second we'll find out something about whether changing to another parallel random number generator actually does make a difference. We're running count ones or one max with a population size of 1,000 and a bit string of 2048 in serial instead of in parallel, which turned out that was easier to fix. Yes, Izitsu, I should totally know better. That'll be easy and fast. That is a dangerous, dangerous thing to say, because it is never, ever true. Okay, so that one actually looks pretty good. Let's grab that. And then we don't have the warm-up stuff. And then let's quick run over here and see if Joe Shiro gets us somewhere. Fingers crossed. Cargo build. Nothing really, other than I had to rerun some stuff because I ran things wrong. So I think this will hopefully tell us something. I think that this is now using, and it's a little faster. Like probably measurably a little faster. Yeah. This is like a second. So this is taking 1.5 seconds off, which is going to be about a sixth. So this is something like 15% faster using Joshiro instead of the built-in thing, which is not bad, right? I mean, that's 15% improvement in most systems would be cause for, quite the celebration. So, and for very little effort. In this example, we're doing a population of 1,000. Yes, we're not just doing random number generation. Like there's a lot of other stuff going on. And this is serial rather than parallel, and the numbers are likely to be different, but yeah, so with Joshiro, copy that, paste. Let's lose this because I don't have that anymore. So that would tell us that 8.746 divided by 7.402. Actually, really what I want is 8.746 minus 7.402 divided by 8.746. Yeah, so it is about 15%. That was pretty good back of the envelope. So that with count ones got us 15%. Let's see what we get with complex regression for funds. So let's see, that's there. That means we just need to change this to complex regression. Boom. And see what that looks like. Let me grab this just before it scrolls off on me. Oh, but I'm potentially messing up the timing. So I'm guessing this will have outliers. So vagary, I wonder what a flame graph of sorting versus randomizing. I'm not sure I understand. Sorting versus randomizing what? I'm not sure I get it. So, okay, well, that seemed happy. So there's that. Boom. Okay. And now I want to change that to use the other random number generator. If we just come over here and grab this. Boom. And we'll have to import some things. Come on. Import. Oh, No. Yes? Ah, I didn't add it to EC push. That's why that didn't work. Or it's just push. There we go. That makes that a lot better. Okay. So now build. And now hyperfine. Yeah, so I've never done any like memory heat profiling. I mean serial here because I haven't added the changes to make it work in parallel. Um, did it error on? Oh, it did. What was it grumpy about? Ah, poop. So I'm actually running the old one. Thank you. What was it grumpy about? Oh, look, right there. I need to import. I need to import some more stuff. And now are we happy? I think we're happy now. Okay, try again. Cargo build. Okay, that looks better. Run it again. So yeah, I have no idea about things like how our stuff interacts with caching. I think that's a great question that I don't know the answer to. Um, and I think that we would need to do some sort of serious profiling to understand what's going on there. Oh, okay. So going back to Vagry's thing, sorting the population for each of objective. Are we sorting the population for each objective? Maybe. Honestly, I don't remember. I feel like the answer is no, because you only really care about the best for the objective, and it's faster to find the best. You can find the best in linear time versus the sort is n log n. And so I think that we're filtering for as good as best with linear. Let's see. So this is now with Joshiro. And that was slower. That was slower. That was slower. Really? So that is 6.450. And the other one, if I can get back to it, I think it's going to be up here. It's going to be where? Oh, is it this one? Yeah, this one was 5669. So this is like substantially slower. So let's try again, because maybe there is a caching thing. So this actually seems to be slowing it down, but maybe that other one was just good luck. Because there is, these could be, I mean, you can get lucky. Things like tree sizes and stuff like that, or genome sizes can matter. And so you can have runs with very substantially different profiles. But yeah, that seems weird. Certainly didn't make it better in noticeable ways. Well, that was taking forever. And let me also look at the timestamp, make sure that we think this is like even. Complex regression. 1142. Yeah, that's probably correct. Whew, so much faster in parallel. So much faster in parallel. Oh, I see what you mean. I did not get that. So, but I don't understand why this is slower with the other random number generator. I wonder if we should also try small range from range and mute rand range. Curious to see if that gets us anywhere. Cargo build and hyperfine. Wah 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 wah. Whoa! Hugely faster. That's weird. That's super strange. Huh. Houston? I don't understand. Oh, and we were using star, right? So star equal much better than plus, right? Because we were using star, yeah. Oh, I was running parallel. Oh, that's why. It was so fast because I was running parallel. Thank you. This is why I shouldn't be allowed out in public. Okay. Now that still is faster though. Or comparable. I don't want to touch too many things because I'll mess up. Yes, the excitement was fleeting, as so often the case. You can convince yourself of things if you're not careful. Data collection really matters. Oh, now I think we're slower. Yeah, we might try the normal RNG again. By default, it's doing 100 generations. We can change that in a flag, but it's doing 100 generations at the moment. So we're doing 1,000 individuals for 100 generations. So we're doing 100,000 individuals. So this is small. Let me grab that. With small. And let's see. Yeah, that's definitely slower. Let's do it with regular again, just to be paranoid. I mean, actually, should I? Rand. Let's do that just to make sure we're getting from the right crate. Oh man. And actually, one thing I didn't mention about GECCO is there were at least 2 occasions where somebody mentioned kind of in passing that they'd had to go and redo their data because they realized there'd been an error. And at least one of those cases was, I think, they weren't super clear about this, but I think that after the paper had been accepted, but before they had submitted the final version, they had realized there'd been an error and they'd rerun the runs. And it hadn't changed the outcome in any meaningful way, but they had gotten slightly different results. And so correctness in people's EC code, I think, is a huge issue that is not talked about, because there are so many mistakes you can make that still lead to something interesting happening, but not the interesting thing you think you're describing in your paper. And I think there's a lot of publications that are broken in that way. Yeah. So let's see. Okay, so that's 6.3, and we had 5.6. So it is definitely higher. But they're all kind of, and as you pointed out, Dota, plus or minus 1.2 seconds. So there's a pretty big spread there. So I think all of these are kind of roughly the same, actually. That changing the random number generator, at least on the serial, is not meaningfully changing things. So going back to your comment, Vagri, yes, we're doing, on the order of 100,000 selection events, and each one of them uses a random permutation of the training cases. That is true. But there's also, there's a lot more than just that, right? There's the randomness in the selection, but there's also randomness in the mutation. So we're using UMAD. So we're running through and making random choices about each of the, for each of the genomes. Are we adding something? Are we changing something? Yeah, right. There's all the actual evolution stuff going on. And so there's randomness in a lot of places in this code. Which is why I thought that if we changed to a faster random number generator, we would see the big win that we have then not seen. So sad. Yeah, so now it jumped up to 7.4 plus or minus 1.5. How big is the genome? The genomes are starting out in this instance as, I think, 50 instructions long with a max of 100 instructions. So, and that's one of the reasons there's such a high variance, is that some runs will move towards smaller genomes and some runs will move toward bigger genomes, and a smaller genome is definitely faster. Like if your average genome size is, if your average genome size is 10, you're going to have a much faster run than if it's 90. No question about that. So it's going to definitely matter. So let's see if we can, oh, that's not going to work. Let's grab Eustace's change to the par next, which is more substantial. Let's actually just be gross and just copy this. And plop that in. I wasn't sure it was the same gist, so I just grabbed the link. So this is going to be over here, and serial next. This is par next. So we're going to just basically replace all of this with that. And am I missing a close curly? I bet I am. I bet I didn't catch. Oh, undo, save. Okay. Cargo build, just to make sure we're all together. And then this we want to be parallel. Oh, but I want this one to be that. Okay, so that's the default, and this is the default, so we should be good. It did make it go faster, so that's a win. But we would hope that parallelism would make it go faster. Yeah, so the parallelism brings it down by about 50%. So they're actually program instructions. So instead of like ACGT, there are things like int dupe and float plus and things like that. But yes, the same basic idea. Count one, no, complex regression as is in parallel. Boom. Da 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 da. I think we see better. I think the parallelism makes more of a difference if we increase the size of the population. Is that true? Actually, I think I saw that at some point, but I don't honestly remember. Okay, so that's that. And now we want to come back here and switch to, I don't know, let's switch to small because it's easy. And then we want, although actually, what did you use? Maybe I should actually care about that. Oh, all right, we're passing something in, so it doesn't really matter. And actually, I want to come all the way down here. Oh, fine. Wanted to come all the way down there. I guess I really just want the whole thing, don't I? Copy everything. And then generation, par next. So I want the entire par next function. Boom. Whoa. Oh, undo. I obviously copied. Oh, well, that was unhelpful. What about raw? That's better. Boo, ba-doo, boo, boo. Da 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 ba 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 bum bop. Okay. So we have to import some things. Did I replace serial? Really? I totally did. Oh my God. Why am I allowed out in public? Par next. Par next. Boom. Okay. Quick fix. Import seedable. Import arc. Import mutex. And everything else looks red. And then complex regression, we're going to need to pass right here. And mute range. Okay, that now compiles. build. Did that work? That's HIF. Actually, here, let's ls minus lt. Look at that. 1150. No, that did not build. Something failed. What failed? That's in HIF. That's in count ones. That's in HIF. So why did that not work? Because this says it's all green. And generation's happy. And those should be... Okay, I'm gonna nuke target just to be paranoid. And we'll see what happens. Let me catch up on the chat. Yeah, so vagary answered your question, Dota. That's not valid. It's checked at runtime. So yes, absolutely checking the. There's a lot of if tests on the oh, hey, there's just nothing there. So it didn't build at all. That's not helpful. What if I say cargo run release example complex regression, and then we'll just see what it yells at me about that. Oh, it ran. Weird. Huh, it died so hard on the other things that it was not catching things correctly. So there are conditionals, coming back to the thing. On every instruction, there's a bunch of conditionals that are checking are the right number of arguments or the right types available on the stacks. So there is a lot of runtime checking that happens, not compile time checking. And so that does certainly take time and could be an area for optimization potentially. And my pot of tea has run out just as the time for the stream is ending. Haha, good time. Yeah, I mean, there's a lot of options there. I think that's an area that vagary is explored a lot, but has, other than vagary, has been largely underexplored. Small range. And so this was actually slightly slower, but not in a statistically meaningful way. So this, we were 2.977 plus or minus 0.4, and this is 3.03 plus or minus 1. So this did not improve things. Okay, we'll try one more thing and then I should wrap up because I got stuff I need to do today. So we're doing rand XOR shift. Is that, oops. Is that in here? Actually, why don't I search here? Rand XOR shift. No. So it's a new thing. Docs.rs rand XOR shift. Okay. Oh. Is this gonna... okay. So, I'm going to need to add it. Cargo add dev rand XOR shift package push. And then, where's my, there we are. I'll just keep chaining these comments because that's got to be annoying to somebody. Rand XOR shift from runge and mute rand runge. Okay. That, why is args yelling at me? Whoa. What happened there? Well, that's not complex regression, so maybe that's not my problem right now. Oh, and then, yeah, that, we have to change it in generation too, correct? No, we pass it in. We don't have to change anything else. So then cargo run just to force it to compile. Bingo. Look at the time stamp just to be paranoid. 07. Yep, that's this minute, so we should be okay. Hyperfine. Go. Okay, so catch up on stream chat. Yes. So yes, there would be 50 instructions of whatever kind, but there could be, that would be, I think, at the current setup, that's the initial thing, but the mutation can make them longer or shorter, so we can get longer or shorter sequences of instructions. And then the fitness function and the lexicase selection. So 3.0, yeah, that didn't really change anything. So that didn't make a big difference. So I think what we've learned today is that at least with the push stuff, random number generation is not the big deal that I thought it was. Well, that's interesting. I think you're probably right that this would be a good place for a flame chart. Cargo run, no, cargo flame chart, flame graph, flame chart. And the binary I want is so is it examples, complex regression, and this doesn't is that going to be the right thing? Yeah, I think the flame graphs don't really, they're very hard to make sense of if they're in parallel. It splits everything up across threads, and it's just, yeah, it's nightmarish to look at. So I think you kind of have to do remove the S. Example. Thank you. Oh, yeah, fine. Okay. And then back over to here, open up. Where are we actually? Documents, unhindered by EC, flamegraph right there. La 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 la. Make that bigger so you can read it. So run to completion is what was that? That is 74% of the runtime. And this R fold, I'm not sure what that's doing. Yes. And then flatten is a little bit. But it's clear that this running the push programs is the big thing, at least with complex regression. I think it's different if we do this on like count ones, but it's certainly not showing up that the random numbers are a big deal. Now I think we can do a search. RNG? No. What was it? It was, yeah, R and so I don't understand. Did it find something or not? Reset, search, rand. Oh, that's what's down here. I'm with you. So the random number generation here is only less than 1% of the overall thing, which is why it's probably one of these tiny threads somewhere. Who knows where? Oh well. Yeah, it would certainly explain why all the fiddling we've done for the last hour and a half hasn't done anything. So it's totally interpreted at the moment. So we don't have. You could do some kind of compilation, but it's totally interpreted at the moment. There is a related approach called code generating GP that uses the evolve program to create an abstract syntax tree, which is then compiled into a real programming language, whatever real programming language you care about. And oh yeah, I could do that. And there you're compiling before you actually run things. And since you're running it on lots of inputs, that potentially wins. So here is an example, thank you to Vagary for suggesting this, of an evolved program. So, and we won't go through all this, but this is basically saying take whatever's on top of the floating point stack and make a copy of it. So there'd be two of them. Well, the floating point stack at the beginning is going to be empty. So that's a no-op. It didn't do anything. Yeah, this doesn't have simplification, so there's a lot, but that actually is probably useful for explaining what's happening. This actually pushes X onto the floating point stack. So X is our input for the the function that we're trying to generate. So this pushes the input onto the floating point stack. This tries to divide the top two things on the floating point stack. Well, there's only one, so that would ignore that instruction. This tries to multiply the top two things. There aren't two things, so it would ignore that instruction. This is going to push 0 onto the floating point stack. This now tries to divide x and 0, and I think it's x divided by 0. Turns out that's going to be 1. So there are two things, and it handles division by 0 by pushing 1 on. So this has replaced the x and the 0 with a 1. This pushes a 1 on. This pushes an x and an x on, and another x on. So we now have 2 1s and 3 x's. And this multiplies the top 2 x's, so that gives us an x squared, pushes another couple of x's, duplicates the top x, blah, 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 right? This is not a program that's designed to be read really by human. The simplification just looks for instructions that don't do anything and removes them. And that only happens at the end for like human readability. So it would get rid of this and these two guys as examples to make the result easier to look at. And yeah, so this would, oh, and yes, and random close bracket. So this is a closed bracket that doesn't really have an open bracket. Yeah, so it's actually doing a hill climbing search process where it removes an instruction, checks to see if the result has the same semantics, like runs it on the test and sees if it has the same output. And if it does, then it says, okay, we'll leave that guy out because it didn't matter. And if it doesn't, then it brings that guy back, and then it just keeps trying removing stuff. And as long as removing things doesn't change things, then it keeps simplifying. And there are totally ways to improve that, but it's just for the reporting at the end. It's not really for anything to do with the actual runtime behavior. And in fact, people have done tests, and if you simplify during runtime, it's probably bad. You actually want to have the extra instructions there during the evolutionary process because they matter, or they can matter downstream. And if you oversimplify too early, it often greatly constrains the evolutionary process, and you don't get good results. And yes, Vagry's point is important. You could get some subblocks that repeat, but having anything very large is not very likely. And that's, I think there are possibilities there, but I think they're not easy. I don't think it's sort of low-hanging fruit on that front. Like I thought random number generation would be, but, you know, Izitsu's giggling in the corner about, you know, how we just spent the last hour. So, okay, I should wrap up. I've got stuff I need to be doing that doesn't involve doing this at the moment. I guess we could do the flame graphs with count ones. Is count ones actually cargo run count ones? Let's make sure it's compiled. Boom, 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 and it doesn't compile. Oh, that's because is it just going to be that? Maybe it's just going to be that. Quick count ones. Probably it is just this. What are we actually doing as our random number generator? Okay, we'll do star. Why? Yay, okay. Now, flame graph, count ones. And minus B 1,000, 2048. Boom, bop. Yeah, fine. Why do you develop with 1,000? I assume you mean population size 1,000, Yeah, probably. I think that some version of Vagary's answer is probably true. Reload. And boom. So actually, let's up. So this is genome scorer is this big flat spot out here. And this is the printing is the other big piece. That's weird. Search rand. Oops. Search rand. Oh, well, here rand is 14%. Okay, there we go. So that, what is that doing? Oh, that's the getting a random slice, partial shuffle. What is that happening in? Oh, this is lexicase. Oh, okay. So in this instance, lexicase is 81% of the time, which was not true. Yeah, so shuffling in lexicase is 8%, and lexicase in total is 81%. You mean this little guy here? That's about Malik should clear. I don't think that's. No, the other pink one. There's another pink one. Oh, I see. Yeah. Okay, so random range is also, but it's also under lexicase. So random range and partial shuffle under lexicase. Oh, and that's why this is probably 6%. Yes. So that's about 6%, and this is 8 something, so they add up to 14%. So here, that's why fiddling with the random number generators might have mattered a little. No, I need to quit. We could do that next week or something if we think we care, but I need to take off. And we've run 23 minutes long, so I'm going to be evil and stop. So I'm going to quit. I'm going to say thank you to everybody for sitting through a crazy bit of like flailing. The stuff on the left is all printing. So this is IO print. So I think this whole stack here is just printing stuff. Yes, absolutely. The premature optimization class is excellent. And, you know, we are printing a lot of stuff here. And there's not much evaluation that has to happen. So I'm not shocked that the printing is eating the world. Whereas with the push stuff, the actual evaluation of push programs is just a lot faster or a lot slower. And so the printing is still probably expensive, but it's costing us less. So, okay, so next week should be normal. Weekend should also be normal. Complex regression was using lexicase. Yes, I checked that, and it was 100% lexicase. So we should have Saturday, 26 July, 2 to 4 p.m. CDT, UTC -5. So more fun with Manum. And then Sunday, 27 July, 2 to 4 10 to noon. CDT. Always lovely to have you, Vagary, and everybody else whenever you can join. Finally, go back to the READMEs for unhindered-ec. Sadly, truly, sadly true. Okay, You're all awesome human beings. Thank you very much for being here. I really appreciate it. We'll see everybody later. Talk to you. Goodbye.